Hi guys, this is Ms. Trejo, and I'm going to do a video today on adding and subtracting fractions. I know that some of you guys were not able to log into the Zoom meeting, so this video is going to go over what we what we talked about during the Zoom meeting. So before we start, I know that we talked about adding and subtracting fractions during class, so I want to do a small little review before we go into our examples. So first, I want to know which of these two fractions am I able to add. So am I able to add A, 2/8 plus 3/5, or B, 1/6 plus 4/6? Which one of these am I able to add already? Okay, and the correct answer is B. So I'm able to add these two fractions only because they already have the same denominator, guys. I can't add these two fractions yet. Now, which of these two fractions am I able to subtract? Am I able to subtract A, 10 over 15 minus 3 over 15, or 8 over 9 minus 2/7? Which one of these am I able to subtract? And the correct answer is A. So I am able to subtract these two fractions, these two fractions only because they already have the same common denominator. So I can't subtract these two fractions yet. So did you remember something as we're going over these little review? That you can only add or subtract fractions if the denominator is the same. If your denominators are not the same, guys, you will not be able to add or subtract your fractions. You must have the same denominator. So if your fractions do not have the same denominator, how do you find it? Well, you do that by finding your least common multiple, or the LCM. And once you have your least common multiple, which if you don't remember, I'm going to show you examples in a little bit. Once you have your least common multiple, or your LCM, then you'll be able to add or subtract your fractions. So because now that you have your least common multiple, you create equivalent fractions for your original fractions in order to be able to add or subtract. So let's jump right into our examples. And you'll see what I mean by equivalent fractions in a little bit. So this example is adding fractions. So Ms. Trejo drank 3/8 of a cup of chocolate milk in the morning. She then drank 3/4 of a cup of milk in the afternoon. How many cups of chocolate milk did she drink today? So how do I know that I need to add in this problem, or that adding will give me my answer? Well, I know that I need to add because I'm asked to look for a total, or to find a total, because it's asking me for how many cups of chocolate milk did she drink today. I don't know that. I only know how many cups she drank in the morning and how many cups she drank in the afternoon. So I have to put these two together to find the total amount of chocolate milk that she drank. So I know I need to add, because I am looking for the total amount of chocolate milk Ms. Trejo drank. Okay. So now, guys, I know that in the morning she drank 3/8, and in the afternoon she drank 3/4 of a cup of chocolate milk. So now I know that I'm adding these two fractions, but I have a problem. They don't have the same denominator. So I need to find the least common multiple. How do I do that? By doing my t-chart. So in your t-chart, you're just going to write the timetables for each of your denominators. So here I'm going to write the timetables for 8. So 8, 16, 24, 32, and 40. And I'm going to stop there. Now, the goal here is to find the first number, or the first multiple, that your two denominators have in common. The first, the least common multiple. So 4, 8, 12, 16, 20. Okay, I'm going to stop there. Now, I see that they have 16 in common, but it's not the first number that they have in common. The first number that they have in common, guys, is 8. So 8 becomes my least common multiple for these two fractions or denominators. But my least common multiple is 8. I already have an 8 in this fraction in 3/8. So do I have to do anything to it? No, I don't have to do anything to it, guys, because I already have 8 as my least common multiple. So this fraction stays the same. So now I have to go with my other fraction. How many times did I have to multiply 4 to get to 8? So 1, 2. So 4 times 2 gives me 8. So now I'm going to here multiply 4 times 2, and that's going to give me 8. And whatever you do to the bottom, you must do to the top. So 3 times 2 gives me 6. So that's my new numerator. Now, this fraction stayed the same because we had the same LCM, but this other fraction is different. But 3/4, guys, is the same as 6/8. They're equivalent fractions, okay? Now, I'm going to already put 8 as my denominator for my answer because when you're adding and subtracting fractions, your denominator doesn't change. It stays the same. So the only thing that you're adding in this case are your numerators. So 3 plus 6 is equal to 9. So now, this fraction, 9/8, is an improper fraction. And I know that because 9 is greater than 8, or your numerator is greater than your denominator. So now, how am I going to transform this improper fraction or simplify this? Well, I have to divide 9 divided by 8 equals. Well, I know that I can only take 8 pieces one time out of 9. So 9 divided by 8 gives me 1. And if I was to subtract 9 minus 8, that gives me 1. So not 1 with a remainder of 1. Now, I have a remainder, right? So you forget about the R and you put your remainder over your denominator, which in this case was 8. So, 9/8 simplified is 1 and 1/8. Kind of like the same thing, guys. If you subtract 8 from 9, so 9 minus 8, it gives you 1. So you have, you can take 1 whole away from the 9, and you're left with only 1 piece. So that remainder that we had to put it over our denominator. So 9/8 is the same thing as 1 and 1/8. So Ms. Trejo drank 1 and 1/8 cups. Whoops, that's too big. Cups of chocolate milk. Alrighty, guys. Now, we're going to go to our second example, subtracting fractions example. So, our problem reads, Ale ate 1/3 of her vegetables. Mario ate 2/5 of his vegetables. How much more veggies did Mario eat than Ale? So, how do I know that I need to subtract? Well, I know I need to subtract. I know that I need to subtract because I am finding a difference, or the difference. The difference between two fractions. So whenever you're looking for how much more, you're looking for a difference, and those are keywords, guys, that tell you that you need to subtract. So in this case, I already knew that I needed to subtract. And what number am I starting with? I'm starting with Mario's, because they're asking how much more veggies did Mario eat than Ale. So my first number, or in this case, my first fraction, is going to be Mario's fraction. And I'm going to subtract from that Ale's fraction. So I already have my expression here, or my equation, 2 over 5, 2/5 minus 1/3 equals something. Well, like we said, we cannot subtract these fractions already because they don't have the same denominators. So I have to find the least common multiple, or the LCM. Now, guys, how do I do that? Well, we're going to do the same thing, guys. We're going to do our t-charts, and then we're going to find the first number they have in common, or the least common multiple. So 5, 10, 15, 20, 25, 30. And I'm going to do my timetables for the 3. So 3, 6, 9, 12, 15, 18, 21. So now looking at both of my timetables, I see that the first number they have in common is 15. So 15 is the least common multiple for 5 and 8. So I'm going to put 15 right here. Now, how many times did I multiply 5 to get to 15? 1, 2, 3. So times 3. And how many times did I multiply 3 to get to 5? Well, 1, 2, 3, 4, 5. To get to 15, guys. Okay. So I know that I have to multiply 5 times 3. 5 times 3. And whatever you do to the bottom, you must do to the top. Okay? So now, let me make this more readable. Now for my for my second fraction, I'm multiplying my denominator by 5. So whatever you do to the bottom, you must do to the top. So I already know, guys, that my numerator for both of my fractions is going to be 15, because that's my least common multiple. But also, I'm going to already put 15 in my answer, because anytime you're adding and subtracting, your denominator doesn't change. So now, I already did 5 times 3. So 2 times 3 is 6. So that's my numerator for my first fraction. And 1 times 5 is 5. So this is my numerator for my second fraction. So now, I already have my equivalent fractions. So 1/3 is the same thing as 5 over 15. And 2/5 is the same thing as 6 over 15. So they're equivalent fractions. So I'm ready to answer my question. So 6 minus 5 gives me 1. So how many more veggies did Mario eat than Ale? Mario, oops, it's too big. Mario ate 1 over 15 more veggies than Ale, or 1/15 veggies more than Ale. Okay? So here my answer would be 1 over 15. All right, guys. So we repeated the same process as when we were adding than when we were subtracting. You cannot forget that you must find the LCM, the least common multiple, in order to add or subtract fractions. If your fractions have the same denominator, then you're good to go. But if your fractions do not have the same denominator, you must find the LCM. And how do you do that? By doing your t-charts. So I hope this video helps you guys. If you have any questions, just send me a message, okay? Bye, guys.